Well, welcome to Harvard, Ben. Welcome to Radcliffe. Thank you so much for coming on this visit.
Thank you, Alyssa.
Yeah, and as I told you when we spoke about this originally, we've had a great deal of interest in artificial intelligence and machine learning in the context of predicting not only what's going to happen to those things in the future, but their ability to predict the future. And that interest came from students who were in a freshman seminar on prediction that happened at Harvard here last fall. And two of our finest students are here with us today. We have Sandip and Han. And so I think the first thing we should do is let them each tell us who they are and let you tell them who you are. And then we can start the conversation. And so maybe we'll start with Ben. And maybe, Ben, you can explain your background quickly, which is going to be difficult for Ben, because, not because he's wordy, but because he's done a lot. Go ahead.
I'm very pleased to be here.
Thanks.
And I come from a background of studying physics, like a lot of people did in my days. And I got sucked into computer science, and I was working as an undergraduate for a physics research group at City College of New York that was connected with Brookhaven National Laboratories, and that's where I got into programming. And programming was so compelling that going to classes got in the way of my education. And I really early on got to do these great projects of 3D reconstruction of particle tracks, and so that was a wonderful experience. And I had also broad and eclectic view of the world, so I was interested in psychology and journalism, lots of other things, humanities, visual arts. My uncle was the legendary photographer David Seymour. My parents were journalists. My sister's an English professor. So there were a lot of different exposures in my world. And at that time, also had some great teachers. Richard Hamming, one of the Turing Award winners, was two-semester teacher at City College when he came from Bell Labs to tell his stories. Anyway, I went on and got into the computing thing in a serious way, and that served me well. And I started out doing database and file design and optimization techniques and indexing strategies and all very traditional computer science stuff. But I began to shift more and more to what I say is 20% of an experimental psychologist. And that was an important move.
Something about the humans using the computer.
That's right. It was, I was going to be a fine database guy, but I thought there was something unique that I was bringing that I didn't see around me. So I had from the start a different perspective. And growing up in New York and Manhattan, in those places, the worlds of art and media were a very rich part. Marshall McLuhan was an important influence on my thinking. I went to see him and talk with him. The Museum of Modern Art figured strongly. So there are a lot of other influences that you can see that took me to a different perspective as a computer scientist. By 1980, I wrote the book Software Psychology, which was the attempt to talk about this marriage of disciplines. And the publisher thought this was a weird book, but we'll do it. And it turned out at that time there were 2 Computer Science Book of the Month clubs, and both of them took it as a featured selection. So
I never knew that there was a Computer Science Book of the Month club. Is there still such a thing?
I don't think so.
Oh, okay, yeah.
So, that gave prominence for this topic, which was great for a young researcher starting out. And so that's how I went down the track. And I've gotten, deeper into the side of human-computer interaction, the user interface, design are the things that drive me. And that has brought me to this table to discuss the issues of the relationship of people and machines. And that's why I'm here.
Great. Okay, and why are you here?
Well, I just think prediction is the future. Machine learning is one of the futures.
It's especially hard if it's about the future. Anyway.
Probably cut that one.
It's okay.
But yeah, I think machine learning is a core important aspect of computer science today, and we're seeing so many strides being made in the public sector and the private sector and in research with machine learning and artificial intelligence. We're trying to predict so much more than we can in the past. We're trying to predict everything from the weather to financial futures. So I think it's the forefront of computer science, and I think it's a really exciting field and the right place to be at this time. So.
And you and Sandra were both freshmen, and so I'm just curious if each of you was very interested in this before you even came to Harvard, or did you get interested in this more recently?
I think if we're interested in computer science, I think it's very hard to not be interested in machine learning, especially like if you're reading the computer science blogs, every day there's something about machine learning coming up on there. I think that's probably the same for you,
Yeah,
Sandra.
exactly. I mean, I think I was first exposed to it in like biological context. So at my school, there's a lot of people doing research. My high school, a lot of people doing research in how to apply machine learning to diagnoses of cancer and other diseases. And so I thought that's a pretty cool application of this technique. I want to see how else it can be applied to other things like Han was just talking about. So I think the fact that it's so ubiquitous in our lives and there's so many potential opportunities is why I think both of us find it really exciting and really interesting to learn about. I think there's so many sort of unanswered questions that, in order for us to consider these questions, we need to understand the principles of machine learning, of artificial intelligence, and see, is it possible for AI to mimic the way that humans and other animals think about the world and approach the world, or is that simply a parallel that we can't draw and that machines have certain limits that they can't transcend? So I think those are some of the questions that I find pretty interesting.
Yeah, well, I also want to know whether we're worried about machines doing better than humans in some way.
Yeah.
But anyway, so why don't I just start by letting you ask Ben some questions?
Well, I've got a question first.
Oh, no, Ben wants to ask his own questions.
I mean, prediction's
Go
been
for
around
it.
for a long time, right? And let's just say a simple extrapolation or correlation has been around. How is machine learning qualitatively different from correlations?
Well, I think all of a sudden we can bring in so much more data than we had the ability to, and I think like a great example, and it's becoming so much easier to do so with significantly less compute power. Like anyone can go on Amazon Web Services machine learning platform and just put a bunch of data in there and just get predictions within like 20 minutes of compute time.
So how is that qualitatively different from a correlation?
Qualitatively different, I don't know if it's significantly different, if that makes sense, but I think the ability that we can bring in so much more data into our like black box of machine learning is, I think, a huge thing because there's so much data
Is
floating
more
around our
data
world.
always better?
If it's good data, I
Makes
hope it's
data
better.
good? How do you know if data is good?
Well, statistically, if it matches within our expected values,
What if
it,
it's
like,
less
correlates well.
relevant? Are there situations where adding more data make a prediction worse?
Probably. So, and that's I think where we have to start to draw the line where what data is relevant, right? Is if you're trying to predict the weather, is something happening on the other side of the world relevant, which we know today
Okay.
it is, or if you're trying to predict the weather
So can you give me circumstances where predictions might be accurate and other cases where you think they'll be less accurate?
So I think one of the hardest ones to do is weather because there's just so many factors to do in it, and we don't really know what factors that it should go in weather. Do we know if cutting down trees in South America affects the weather in North America over the long scale? How do we account for those types of things? So those are things that we haven't really thought about. I think when we're trying to build out these
People
models,
have thought about that. But
we are thinking about those as we are trying to build through these models to.
yeah, but you believe the butterfly in Beijing changes the weather.
I think that it might. We don't know
Right.
yet.
How would you find out?
I think it's going to take a lot more
A lot of
research and
butterflies.
modeling.
Okay, fair enough. Good. Thank you.
Yeah, I would say, I think one advantage that modern artificial intelligence machine learning techniques give us is the ability to look at a lot of different factors and really have a very deep analysis. And so when you look at things like, like deep neural networks where you can have multiple layers of connectivity, I think that's a serious advantage over a simple correlation where you're looking at a couple factors and trying to see if they're, if there's a relationship
Sure.
or not.
Multiple correlations give you a little bit more, right?
Yeah.
So, there's not, I think there's a little danger of the assumption that somehow there's magic pixie dust when you say neural networks and machine learning and you say, oh, magic things are going to happen. And I don't think that's true.
Is the magic pixie dust possibly that we don't understand what's going on, whereas in a correlation it's simple enough
that's
that
right.
we understand?
That's right. Well, correlations can be complicated too.
True, but we have hope.
I agree. There's more complexity, which
Right.
suggests a real danger.
Right.
So it may be less accurate in its predictions, and the unfortunate trust and belief and fantasy that people have that these things will have a correct prediction is what really worries me. So you know the story of Google flu trends? Google flu trends?
Go ahead and tell everyone.
All right. So around 2009, Google began to say, well, we might be able to predict the way flu breaks out in different cities around the country by looking at the queries that people put to Google. And so if they ask for tissues or aspirin or flu symptoms or so on, we could get it. And in fact, their early results showed, wow, that the search queries people ask in different cities were early predictors of flu outbreaks well before they appeared in the hospital rooms. Okay? It turned out there were other predictors like sales at Safeway of tissues, okay, or another form of prediction. Anyway, there was great excitement about Google Flu Trends, and it was shown to be predictive, and therefore public health assets could be allocated in a more rational way. Unfortunately, it didn't work, and it began to lead to incorrect predictions, okay, that led to poorer allocation of resources. By 2013, Google removed the Google Flu Trends website from the web.
And is this because it ran away at some point, trying to improve itself?
Now, you can join the debate about why this one went
I'm
there.
just curious. No,
it's
I
a well-documented,
opinion.
popular one. And if you read David Laser, you may know David Laser, a wonderful researcher, and he and colleagues wrote a wonderful 3-page article in Science that described this fiasco. And there were 2 things. Algorithmic hubris. The assumption, the misleading, mistaken assumption that the algorithms were going to get it right. The other was their unawareness of the constant dynamics of change in the world and in the Google search engine strategies, that every day there are dozens or hundreds of tweaks. And eventually, the Google search engine began to drift off, and it no longer became predictive. So this was a really instructive lesson, and I would say that should be part of your course on prediction. That's a 3-page article, beautifully written.
We will definitely link it to this very discussion.
And it's important, if you're going to be researchers or scientists or students, that you look not only at those wonderful, breathtaking stories about how great it's going to be, but you also understand the failures. We were talking about failures before,
Right.
and understanding why things didn't work out. So I'm on the side of some cautions here. Yes, machine learning, neural networks have great opportunities, but the mindless acceptance of their potency is extremely dangerous because that leads to deadly outcomes. Talk about Tesla car crashes in a while, but go ahead.
So why did Google choose not to continually try to work on the flu tracker?
That's a good question. You'll have to ask them that.
Because they could have just adjusted their
They could have.
algorithms
They
to
could
try
have
to
continued to
keep on
adjust.
matching and try
But
to.
it was something of an embarrassment, and I think a real problem. And it's a good question. I might say I wish David Laser had asked that question. One of the few critics
Google.
I have of that article was actually they could have talked to the Google engineers who did it and try to find out what their responses were. That would have been a nice way to bring that together. That is, getting in touch with the real people is something you should practice in any kind of science, any kind of research. You should actually talk to the people, not just buy the hype.
Did you guys all see the AlphaGo documentary?
I didn't.
You didn't? Well, it's wonderful. And actually, the team there from Google, DeepMind, works very closely with 2 champions, Go champions. One who is the Korean champion, who's the champion of the world, who in the end loses 4 out of 5 matches. But the first one, who lost 5 out of 5, was the European champion. And he became the partner with Google DeepMind as they made the algorithm better and better in preparation to play the Korean, who was the huge champion. And that kind of partnership is something I really hope we can come back to later, where you admit that you don't want to have this complete hubris, and you have the human and the computer in whatever kind of partnership you can have. And of course, this failing or fallacy that you're pointing to about people not understanding what the algorithms that they're doing that they're making are doing, and just letting them go, is the core of this problem. But of course, if you can't understand, it's also hard to figure out how to do these partnerships. So I would love to come back to that later.
I want to come back to it, but I just want to leave something on the table, that an important part of our discussion has to be about the language we use. And so I'm very concerned about the use of the word partnerships.
Okay.
I do not think that machines are our partners.
Oh, okay.
All right?
What are they?
They're tools.
Okay.
Is this a partner? Are you
No.
a partner with your, are you a partner with your car?
Sometimes I eerily feel
You
that I
think
am
so?
a partner with my phone.
Then, well,
See,
that's-
this is what's happening
there
to
can
people.
be drifts in your
Anybody
thinking.
else feel that
But
way?
I think there's, similarly, I will,
Yes.
suggest that machines are neither partners, collaborators, or, assistants.
But you hear that a lot, and so
You
you
do.
must object a
That's
lot.
part of the
Okay.
problem I have. That's part of the
Fascinating.
things I think we need to change. I hope your course will address this to give a balanced view, because so far what I've heard in the language suggests, a dangerously pro AI, unthinking, a dangerous one. We'll come back to that. Okay, so
All
I
right,
just leave
Sand,
the
if you-
language we use is important to me.
I mean, I guess kind of going off of that, I mean, I think a lot of things, eventually I think machines will be able to mimic a lot of things that we do, right? I mean, if it's like, composing a piece of music, it seems pretty challenging for a machine right now to compose something very original like that. But it's feasible that someday they could, mimic that process if we understand how humans do it well enough. At that point where machines are able to mimic a lot of things that we do, what will be the distinguishing factor between a very smart machine and a person?
Very common question. And I'll go back to the words again. Mimic. Does your iPhone or iPod, when it plays music, is it mimicking a musician?
Not really. It's just kind of
Really? Thank you.
Yeah.
Okay, it's not. Okay. Is a telescope mimicking your eye?
I mean, it's a tool for you, right?
Thank you. It's a tool. Is a bulldozer mimicking your hands?
Definitely not.
Is a car mimicking your feet? Is an airplane mimicking a bird?
So you're saying they're enhancements of the same function.
They're tools.
Yeah.
And the sooner we come to understand that the goal of good design is not to build machines that mimic or replace humans, but to build machines that are tools that empower people. So they're always tools. Tool is a very simple metaphor. I stick with it. It works. I'm very influenced by Lewis Mumford, book Techniques in Civilization, 1934. Well worth reading, 600 pages of poetry about technology and civilization. And in there, he's got a gift for me called The Obstacle of Animism. The Obstacle of Animism. And he relates how every technology goes through an early phase in which the design is meant to mimic human form or animal forms, okay? And, he recounts many such examples. And his point is that that obstacle of animism is a hindrance to project. Only when you transcend that and you now think of the way you build tools that empower people, do you really get the powerful technologies. So I just suggest to you there's a long history where the successful technologies are delayed by efforts to mimic human form or action. The computer systems, the first stage of that has happened. Minsky and the other early AI people believed that you would build simulations of human mind and thinking. Marvin, who I had memorable discussions, dinners with, was adamant that the only valid research was to mimic human ways of thinking, and he was opposed to machine learning, opposed to statistical processes and natural language comprehension by statistical methods. And he's sadly gone, but positively his ideas have now faded, and the notions that statistical methods could become these powerful tools has risen. So the first stage of the decoupling of design of technology from the mimicry game has begun to happen. So I'm hopeful that it will go in the direction. The sooner it goes there, the sooner you two take it down there, the better your work will be.
Makes sense. Yeah, I feel like, it's a lot of people will say, like, how do we know that the human mind functions differently than some sort of statistical function? I mean, you could argue that the human mind is just some sort of takes an input, produces an output, right? So it's very mathematical in that way. So I guess a lot of the counter argument that I'd hear to what you're saying is that, how do we know that the human mind is any different from what we're doing? And so
how is the human mind different from what we're doing?
From what we're creating in machines. And so these statistical methods, how do we know that that's not how our minds work, I guess?
Well, there's many levels of analysis. I hope you'll agree that a computer chip is not like a neuron?
I mean, I think people are like Intel's trying to develop their brain-inspired chips. So I think there's a lot of,
They call it a neuron. They call it a brain on chip. It's not.
I know.
It's not. It's only a metaphor, and it's a
Right.
seductive one that too many people buy into. So at the level of chips, right? Okay, at the level of hardware architecture, or memory, or other things, is the brain what's happening on your iPhone? No. Okay. I mean, and we get ambitious powers because my iPhone has a storage capacity of certain things, of certain accuracy, far greater than my brain, or far different. My brain has other capabilities. The sooner we recognize the differences, the more we'll get there. So we'll be building the tools, and if we go at the higher levels of the forms of communication, does your iPhone communicate to you in the same way that you communicate with me? No.
Very poorly.
Very poorly. It's the machine and the iPhone or displays are remarkable because they're visual and they present a huge amount of information, more than I could present. Okay? And so we interact with each other in a certain way, but we use computers because they're largely visual interfaces. Now, we do also have voice interfaces and so on, and there may be, modest ways in which there will be other capacities to interact. But do remember that computers, for this time in history, and I believe for a long time to come, the visual interface is where the action is.
So let me ask you a question, all of you, on a kind of a slightly different direction. Something about something positive, and I'll try not to use the word partnership. Okay, so one of the things that we're really concerned about in the whole prediction project is getting people to understand that there can be unexpected inputs to predictive models, that things can happen that you didn't anticipate that change everything. And so sometimes these are good things. So for example, there's this famous prediction by Malthus that the whole world would starve because you couldn't grow enough food to feed the population explosion. And then nitrogen fertilizer, and that changed everything. Okay? So I often say to my colleagues who study climate, what's likely to be the place where we find the nitrogen fertilizer of climate? And so imagine the following scenario. Imagine the AlphaGo story, okay, where in that story, even the Korean player, even in the course of the 5 matches that they document in the film, he learns from the computer. So the computer does completely outlandish, unexpected things that all the human players watching the tournament go, what? Okay, and then he's like, all right, you're going to do something out outlandish? I'll try to figure out, I won't say mimic, I'll try to do something similar, okay, to that. And even in the course of just these 5 matches, he says that he changes his strategy. And so then in the talking of the, over the documentary, the narrators talk about how, and the people being interviewed talk about how, well, maybe in the future we'll get ideas from these algorithms, and then we'll go back and forth between human-generated ideas and computer-generated ideas. So what if a computer generates the equivalent of nitrogen fertilizer, okay, in terms of solving the climate challenges, and we don't know how it did it or why, okay, but it works. Am I supposed to be afraid of that? See, I got it.
I think, a reasonable question. First of all, just again, if we stick to the language, the computer generated.
Okay. With a lot of human help, yes.
Thank you.
Yes, not all on its own.
Computers
No Skynet
are
yet.
not agents that,
Yeah.
just go off and do what they want
Although
to do.
you realize people talk about it like that all the time.
That's right. So
Okay.
there's a language problem here.
Right.
And we come back to expectations
Okay.
shaped by language and metaphor. So those are really important to me. And
Right.
I'm getting increasingly, excuse me if I'm getting too much, but I'm increasingly, forceful in sort of asserting the linguistic issues
Right.
in a discussion here.
Right.
Because computers don't do anything. They do what the programmers tell them to do. Yes, are they getting increasingly complicated? Is it harder to detect? Yes. As I'll say in my talk this afternoon, if it's getting so complicated you don't understand what it's doing, throw it out or stop it right there.
But what?
Okay.
There's my nitrogen
Okay.
fertilizer question.
Right.
What if
So-
I didn't understand it, but
Okay,
it still
so
works?
it still may be interesting, but I would say that's a little bit risky, and you need to be careful. So goes back to my earlier question to you. There's different situations. If I have an airbag deployer, I want it to operate in a predictable, reliable way. I don't want it to go off and kill my baby in the front seat, which is what happened for the first for the first years of airbags, because the designers didn't anticipate this. They didn't think about it. So about 100 kids a year were killed by inappropriate design because the designers just didn't expect this stuff. So we need reliability, you need predictability, controllability. And the control became, because you could set the issues about whether the passenger seat airbag would be triggered in different ways. So those become the mediators. Those words get to be shaped over time, and then we have to find new ways to interpret comprehensible, predictable, and controllable. Those are our remaining challenges. Now, we can still let algorithms run in things that are not life critical and watch what happens in playing AlphaGo or chess. That's fine. Let's play around. I see I'm ready to see, and maybe we'll learn something from that. We might learn more if the algorithms were made in a way that they were explainable.
What's very interesting, there's a
Okay,
room
that's
full of
such an
people in the
issue.
AlphaGo documentary that are the programmers who created this, and they all have their own screens with diagnostics of what the program is doing as the match is being played. So they actually are trying to learn. And one of
I
the
think
people
that's
looking
the
at the
right
screens
direction.
is this European champion who's the partner.
I'll take a look at that. Yeah.
So, anyway, but what do you think? Would you work on the nitrogen fertilizer for climate even if you don't know what's going on?
Well, I think we have to be careful with that example because I'm in environmental engineering, and apparently,
Yeah.
like nitrogen fertilizer is one of the worst things for climate.
Yes, that's true.
It's like
That's
kind of opposite
That's
there.
true. Well, I'm sorry. We're using it as an analogy, not as a direct
Just an-
input.
kind of-
Sorry. Yes.
But I do think those so how do you know when you have an input or you have a mix of inputs and something unexpected happens? So what are the ways, how should we train, I guess, our future computer scientists and our future data scientists who are looking at this to understand these? And is there a concern that people who are using these machine learning tools are not fully aware of the implications that they can have? They don't know, again, they're treating it as a black box. You put some stuff in, some stuff comes out, but again, are you using this stuff incorrectly to make predictions that could change the world in some way, or that could have impacts on like human health and life?
We're getting closer to the point. I think this discrimination about the things that are playful, exploratory, and fun or game-like is one set of things. As we move down the road towards financial applications which have consequences, and then towards life-critical medical and other applications, we have to have different degrees of concern. And I think that's appropriate. That's beginning to emerge. And I think those AI engineers and programmers are finally getting around to understand that they need a little bit of richer model of what they're doing, and therefore better control, better representations of what's happening. Google's AI project, Fernanda Viegas, has presented us last month with powerful examples about how visualization could enable programmers, managers to understand what's going on better, okay? And, the complexity that we build in these systems may be necessary, maybe not. There's others, like Cynthia Rudin's work, has shown that the black box methods of doing parole prediction could be replaced quite nicely with a very simple 5-line white box solution, which people would understand. And so I think there's hope in what's called FAT-ML, Fair, Accountable, and Transparent Machine Learning. There's 4 years of conferences. Take a look at the research in that stream of work. And the DARPA Explainable AI program is another place you'll see where people are seriously working on this notion of fixing what I see as the excesses of early AI work.
So do you feel that the companies that are so if I'm a software developer, an engineer, right, building an app or something, and I want to just drop machine learning into my platform, I can easily go and use Google's TensorFlow project, or Apple and now is bundling machine learning in Swift and the iOS SDK. And so there are all these now third-party tools. And I don't really understand how this works, but I can very easily drop it in and follow the documentation and start generating predictions and getting data, putting data in and getting data out. So do you think there is a part on the creators of this, who are the PhDs and the data scientists working at Apple and Google and Facebook, who are creating these frameworks from the beginning to try to put these warning labels, I guess, in their documentation, use it with caution, be aware of what you're doing, and trying to help educate the people who use it.
Warning labels are one thing, but I'm talking about the structural redesign of the systems that make them safe. I mean, that's the talk this afternoon, but the appropriate forms of modular design that allow you to monitor the stages so that when something goes wrong, you actually can see where it's gone wrong. The idea of logging, an audit trail, essentially a flight data recorder, right? You know, when a 777 crosses the Atlantic, it's about a petabyte of data. It's a lot of data, it's overwhelming, we can't understand it, but we can because the tools have been built. And the choice of what to log has been made in judicious ways. That's a mature field. It's a good model because the safety is impressive. And so the idea that there'd be a flight data recorder for every AI program that has consequences, and that when things go wrong, there's a way to retrospectively go back and figure out so that you say, I can prevent this next time, okay? If you say, we can't figure out what it's doing, made a mistake, I'm sorry, shut it down, okay? And that's exactly what's happening. If you read the NTSB, National Transportation Safety Board's review of the Tesla crash that killed the driver last year, one of their recommendations is better logging. And there have been 33 deaths by robots in manufacturing in the US. Only 2 of them are well understood as far as I go. So again, I see the evidence all around me that there's opportunities to dramatically improve the way advanced automation systems work by the really proper engineering and technology.
Do you feel that like the current pace of development, I mean, there's, every day you hear some new application of AI, like, wow, like we're going to solve all these different problems. Do you think the current pace is too fast? And assuming the answer is yes to that question, what are some ways in which we can still have a very innovative culture in our country, but make sure that we're doing this in a systematic manner? What are some ways we can do
Again, a graded approach. Sure, keep that fast development going, new ideas in a research environment on toy problems, on discretionary use and so on. All that's good. If you want to change recommenders, okay. But I'm worried when you start going to a manufacturing control system, financial systems, loan, mortgage systems, medical devices, and so on. And we need to build in the proper levels of protection. Our friends in this will be the insurance industry, that you won't be able to get insurance for equipment which hasn't been properly validated.
Mm-hmm. Do you think that the general public needs to understand more about this?
Sure.
Yeah. And how do you think that's happening or not happening?
Well, I'm here today.
Yes, good. Thank you.
I hope by way of your work and your classes and your colleagues, you will change the attitudes that people have. So there's various bottom-up approaches. I mean, I've written about this in the past. I'll continue to do more. I'm working with colleagues to try to create a new ethic. I mentioned these major forces of the DARPA explainable AI projects, the FAT-ML community. There are others working in this direction. So I'm hopeful that there can be technical ways that improve. Now, we'll never get to a perfect and a safe, 100% reliable, but we need to go to systems like air systems that, when a crash occurs, when a failure is, we understand what happens. And we know we
people
can prevent
certainly
that.
understand what a plane crash is, and they certainly understand when they're flying on a plane.
Yep.
Maybe they don't understand that planes are so much safer than cars, no matter how many times you tell them, the statistics, because they fail in such dramatic ways. But I guess what I'm asking is, and we talked about this in the seminar a little bit, your students, your peers who are students in their, early 20s, for example, when they look on Google Maps and try to predict how long it's going to take to get somewhere, do they ever think about what went into that prediction? Do they think about the learning behind that, or if you ask them how does it work, do they know?
I think most people just say, oh,
awesome,
Google Maps gets me from point A to point B in the fastest way possible.
So let's take that one apart. There is another sort of level of discussion here. Where's the AI in Google Maps?
Is there even any in the original version
Thank
of
you.
Google Maps?
Thank you.
There was
I
no
don't think
need.
so. It was very algorithmic. There's another linguistic problem in general public, since you raised that, which is the word AI is sprinkled over everything.
Right.
And any automation system, AI to me is a small part of the world. I mean, most of what goes on over here on your phone is no AI. Sending email is not AI, right?
I wish it was.
Dominant, form. So, AI is a tool. It's a small tool, but for me, and here I admit I'm probably a little biased and an extreme view, but AI is a subfield of HCI, of human-computer interaction. Human-computer interaction is the driving force of why 3 billion people have something like this in their pocket that they can use. It's the reason the web works, because of good design of user interfaces. Now, we've begun to see the infusion, and most commonly as recommender systems, and also then behind the stack, there's things about the routing algorithms in the web. There's also things about the advertising algorithms on Facebook. So that's gotten a lot of visible attention lately, and Zuckerberg's testimony to Congress last week was fascinating. I did listen to it all, and his 12 times citing AI is going to fix that. It's a little bit, again, pixie dust sprinkled.
Well, Google Maps does learn how you drive.
Yeah.
And so it learns. It's not clear.
Do we have to
how it
argue
learns.
about the word learn?
No, but I think people are confused between learning and machine learning, and sort of improving an algorithm in a way that is explainable and a way that's not explainable. And so, I drive too fast
I would say
sometimes,
that
and it knows that.
Knows. Do we have to argue about this, whether it knows
I think I
anything?
should just make pictures for
Yeah.
No worries.
I think the language we use has been problematic.
It predicts correctly.
Right. So, in writing my book, The Designing User Interface, now in the 6th edition, I've always been very careful about linguistic things, about male, female, use of neutral language, but also I'm careful to not use the word the machine knows. Mm-hmm. It may record. There are certain words I prefer, like it records or it retrieves. So there's certain things that I want to present that it's a more mechanical aspect. I don't want to slip down the path of suggesting this magical machine is like us, because that gets you into a lot of mistaken assumptions. So Google Maps, which is quite a wonderful, remarkable application, depends on some very powerful routing algorithms. Initially, it had, that was the main feature. And it has, over time, the routing algorithms have been improved by the feedback and the study of its use. I'm not sure there are, at this point, even any machine learning neural network approaches that are used. They may be, but they're sort of a component of the system. They're not what makes Google Maps or any map program work. They're not what makes email work. Right. There's other things going on, and so we need to be careful. There's a current infatuation and hype curve around AI that's so prevalent and disturbing to me, so I'm ready to speak up for it.
So do you feel then, kind of to shift the conversation a little bit, do you feel that there's a limit where we should not be applying AI anymore? So Facebook's been in the news recently, and for our computer science class, we had to do a social responsibility assignment, which was writing just a few paragraph essay, but talking, and we were given an article, which is that Facebook could now predict they could predict potential mental stress, mental health issues based on the data that they're collecting. Now, we don't know if it's AI or machine learning using those predictions, but should machine learning and artificial intelligence be used to those applications? And I think in our PredictionX seminar class, we discussed how Target could tell someone was pregnant before her dad knew she was pregnant. That's, I think, a pretty famous example. So where is the boundary that we should be drawing in the line now for the implementation of artificial intelligence?
I think you're probably going to guess also. I mean, there are problems that are lightweight in recommender systems or advertising systems. They may become more serious if advertising is used for political influence. And there are more serious problems when you're talking about job hiring and firing, parole, and other decisions, financial decisions. And then it gets more serious when you get to life-critical applications, whether it's control rooms or aircraft or medical devices. So I think, again, a more nuanced understanding of the spectrum of applications is really important. So, the Target story is a cute one of detecting, but a little caution there also. It had a predictive model that was 84% correct. And therefore, is that good enough to be used in a commercial setting? I don't know. If it offends people, there's some situations, and you know the stories, again, study the failures, where AI systems were put out, and a single failure where a Microsoft application wound up being anti-Semitic, where another one was anti-black. One bad outcome destroyed the system. And I think those may be overreactions of the public, but they're the reality. So some applications, 84% is okay. Some applications, 98% is not okay. And 99.9% is not okay. All right? When we get to driverless cars, and I'm all in favor of developing cars with higher levels of automation, but actually I'm going to, on my flight up, there was a story in the Times.
By the way, I'm still waiting for my Tesla 3. It's on order.
You're good, yeah.
Whether I'll take my hands off the wheel, I'm not sure.
Right. So Elon Musk said excessive automation at Tesla was a mistake.
And the factories, the robots, right?
No, in the car.
Oh, really? Because I read something else then. Okay.
To be maybe he did mean the manufacturer. Maybe you're right.
The-
To be precise, my mistake. He was taking responsibility. Humans are underrated.
Yeah, he said that. Yeah, he did say that.
I thought that was,
But actually, it's
quotable
not
item.
to contradict, but it's actually even more interesting. So the whole story is that Elon Musk was talking about how he was sleeping in the factory and trying to improve the assembly line, which is so automated. And what he said was that they went too fast in automating so many of these processes in the production, and that's where he said that humans are underrated. But what's so interesting is that's not stopping him from making this gigantic fleet of hundreds of thousands of self-driving
but
cars.
look how his mistaken assumptions about the capacity of, and he said automation, not, AI necessarily, but that's kind of a blurred boundary. The mistaken assumptions has cost him hundreds of millions of dollars, maybe more in terms of goodwill and appreciation, and the long waiting times that people have are a serious
In the history
concern.
of technology, Ben, there's been things that are always the precursor of the good answer, right? So the Apple Newton, right, was kind of a flop, but it was the precursor of an iPhone. Okay, and so I wonder if some of the applications that we see today that use a lot of machine learning and artificial intelligence are the precursor of something that works even better, that is much more reliable in the future. And then what happens
Two
to
comments.
people and computers?
Why was the Newton a flop?
It was too big and too slow and too cumbersome to use, in my opinion.
Fair. Okay. I would say there was an unrealistic assumption that recognition of handwriting could be done, and it wasn't good enough.
I had one of those Palm Pilots that worked like that. It was great.
It wasn't good enough for that application. The degree of reliability you need for those applications was not matched. So the unreasonable expectation, the bulk, and the other things are possible concerns. So, that's kind of one trajectory. Also, I would say the other thing, my job is to make sure that technologies get fielded successfully and safely in 5 years, not 15 years. I think if we exercise good judgment and good design and we get things right, we can get successful technologies done, clean up the problems in 5 years rather than have it delayed 15. The obstacle of animism delays successful implementations of technologies.
We're talking about how an 84% success rate for some prediction could be good in some cases, could be bad in some cases. But if we consider something like medicine, where let's say you have a neurosurgeon or some very high skilled person, they're still not infallible, right? And so if we look at if a neurosurgeon can perform a surgery correctly 95% of the time, but a machine can perform it successfully like 98% of the time, would a patient trust a machine over a neurosurgeon, even though on paper it's better, but is that trust in humans?
There's an underlying question about it and the way you phrase it. So who's responsible for the failure? When that patient dies, who pays damages? If it's a machine or the doctor?
I'm not sure who would pay if it's the machine. I really don't know.
Figure that one out.
Yeah.
That's not a good, acceptable answer in a real world situation, okay? So I said the insurance companies will play a role, but the key is responsibility for failures, okay? And so, you may have seen the television commercial, Hotel Trivago, this paired associate, Hotel Trivago, and I've got one too. Safety, responsibility. Safety, responsibility. If you want safe systems, you must clarify responsibility. That's the way you're going to get better systems sooner. So, if that robot is designed in a way, and the company that builds it or the company that fields it say, we will pay you damages if there's a failure, I'm more trustworthy. I like automated systems. Elevators are our favorite example. We have quite reliable and trusted systems, and we work it well. Is the elevator doing the job of the elevator operator? I don't know. It's just a machine. It's just a tool. I get in, I push the button of 7, and it better go to 7. If it goes to 14, I don't like prediction models there. I just want it to go.
Actually, those elevators with no buttons are very scary.
They're very
those,
scary.
Right?
Why are they scary?
Because they're optimizing some positions of the elevators that you don't understand.
They fail the principle of comprehensible, predictable, and controllable.
Yeah.
They're out of control.
Yeah.
You don't quite know what's going to happen, and that's okay. Now, those, I've been in those, and I think they could be improved by better displays.
That's
and
true.
Similarly, many of the airline crashes that I've studied are because the autopilot had so many modes and so many conditions, and the display to the pilot of the current status was inadequate, so they didn't know, and I could go into detail about it. Let me close, if we are, then. You had asked me about making a prediction.
Yes, I have.
So I'm going to predict that 100 years from now, people will look back at the bizarre but maybe quaint attitude in the early part of the 21st century when people actually believed that machines were becoming intelligent, smart, and human-like.
Wow, that's a bold one.
That's right. And that we will see ever more clearly that computers are just tools and that people are really different and special. There's an unbounded creative capacity that humans have, and computers are tools, powerful, complex tools, and we'll think of them like we think of steam engines. There was a great fantasy in the 19th century of having horse races against steam engines, okay? Or bulldozers against people, And we think of them as rather quaint, and I think the same thing will be quaint. The AlphaGo or chess games will be useful and quaint. People will still play chess and Alpha and Go. They'll still be playing those things, and they'll be powerful computers, and we'll go on and, we'll look back and smile at those people who had this idea.
I just hope that something solves climate change in the meanwhile, so we can have that conversation.
Maybe people will solve climate change.
Right, fantastic.
But that's my prediction, that the current infatuation will dissipate even as we get more powerful computers. This will come to appreciate the differences, not the similarities, and we'll know that people have the capacity for unbounded creative innovation, and computers are just tools with no more intelligence than a wooden pencil.
All right, and with future medicine, these two have some chance of still being alive in 100 years. So what do you think?
Come back and tell us, right?
I'm hopeful that I think the climate change problem, for example, will be solved, I think, by humans. I think we're at the point, though, where a computer can't really solve it. We need to take, this is now a physical solution that we need. It's no longer a computational solution that we have. And
I don't know. I think that the computers
can help.
They're not partners. They're tools that will be used very effectively by the humans devoting a huge amount of effort.
That's right. I feel validated from today. That's good. That
Educated
alone was worth it.
All right, Sandy, what do you think?
Yeah, I'm hopeful that humans can. I'm hopeful that humans can stand out from machines, and I know that there's a lot of belief to the contrary in our society, and so I guess we'll kind of see how it goes. But I definitely think that if humans can stay ahead of the machines and do things differently, I think that'll be good proof that there is something unique about human beings as opposed to these machines. So.
All right, excellent. Well, thank you all
Thank
very
you.
much. Okay, terrific.